Hi, we are Team Decoders 25 representing our idea for the Smart Indian Hackathon 2025 under the hardware category. Our project title is Sign Language Capture and Illustration System with Sensor Integration. Now, the problem statement. Millions of people with hearing, speech impairments face difficulties communication in education, healthcare, and workplaces. Most people in India do not understand Indian Sign Languages (ISL), which creates barriers to inclusion and employment. Here, the slide emphasizes the social problem, communication inequality. The lack of ISL literacy among the general population prevents effective inclusion of hearing impaired individuals. Our project aims to eliminate this gap by providing a technological bridge that converts the ISL gesture into text to visual speech formats for better mutual understanding. Technical approach uses affordable sensors such as flex and IMU to detect hand and finger movement. Employs ML machine learning. It includes the TensorFlow Python for gesture recognition. Provides real-time translation of sign gesture to text, speech, or 3D visual output. The hardware layer, wearable gloves or sensor bands capture finger bends and hand orientation, while the software layer, machine learning model trains on the ISL datasets processes signals. Output layer displays the text, speech, or 3D illustration to enhance clarity and learning. The system architecture, which includes the input layer, processing layer, translation layer, integration layer. The hybrid CNN LSTM architecture includes the training phase. Here, data collection will be take place. Then, once the collected data will be pre-processed, normalization, augmentation. Then the model training. Once data is collected and processed, the data is used for training the model using CNN for spatial and LSTM for the temporal. Validation, cross validation, hyperparameter tuning, optimization, model quantization for the development. Inference space includes the input, windowing, prediction, post processing, and the output. ML model, which includes the architecture of the CNN plus LSTM and TensorFlow Lite for the Edge AI part, and input for includes the flex sensor reading plus IMU and the camera landmarks, and output includes the ISL gesture that will be in the form of text, speech, or 3D animation. Workflow. Workflow includes the input part. Here, user performs a sign gesture wearing sensor embedded gloves. Data capture. Flex and IMU sensor detect fingers and blend angles and hand motion processing. Microcontroller sends sensor data to the ML model for classification. Recognition. Model identifies the ISL gesture. The output system converts into text, speech, or 3D animation for the listener. Now, processing. Processing includes the gesture capture, data acquisition, processing, output, visualization. Feasibility and viability. Technical. It includes low-cost sensor and open-source ML libraries. And the operational. Simple to operate, minimal training required. Economic. Prototype cost around 3,000 to 5,000. Scalable and open-source model. Risks. It includes, in the sense it ensures privacy, uses reliable hardware, compiles with the Act 2016. Impacts and benefits. Social impacts and benefits includes the bridges communication gaps for hearing, speech impaired individuals. Education enables faster ISL learning through 3D illustration. Economic, low cost assistive device, scalable in the institutions. Innovation combines sensor plus vision based recognition for accuracy. Sustainability, work offline, no dependency on the cloud. Research and references. The ISL recognition translating gesture into text or speech. IET research says that gestures into the text or speech. Gesture recognition and illustration can be done on the CNN based hand recognition using HSV color space, MDPI. The overall conclusion of the project includes the project sign language capture and illustration system with sensor integration proposes a human-centric innovation combining affordable hardware and AI to promote inclusive communication. It aligns perfectly